Hi guys, welcome back. In this video, we are going to continue our discussion on DC circuits. In previous video, we have discussed about that what we call Kirchhoff's laws and superposition theorem. In this video, we will discuss about star delta transformation. Like what is meant by star? This is star configuration. If in question, if we ask convert this star configuration into this delta configuration, we have some formulas. And if in question, if he gives this delta configuration and if he asks to convert into a star configuration, we have some other formulas. I'm not going to derive those formulas in this lecture. I'm going to directly give you the formulas. Just by heart the formulas and remember them. That's it. Your work will be done. Like why we are converting this star delta transformation. We will just look at basic intro of this thing. Like in series and parallel connections, electrical components may be connected in star delta configuration, as shown in the figures below, just like this. Many times, circuits may have to be transformed from star to equivalent delta and delta to equivalent star configuration such that net terminal resistance across the terminals are same. Like in some configurations, we have to convert this star into delta so that the potentials over here and over here might become same. And in some configurations, we have to convert this delta into star so that the potentials over here and over here will be same. If these potentials are same, then we can consider what we call this all the equivalent circuits are in parallel, right? That's the basic funda behind these transformations. We will know these transformation methodology and resulting configurations for both star and star delta one by one. Let's see. For conversion of, like, I will give you some blind rules. If we are having this Rx, Ry, and Rz, then consider it as a star. Wherever I'm using Rx, Ry, Rz, it's for star. And R1, R2, R3 is for delta. That in the sense, if I'm writing some R1 is equal to some function of Rx, comma, Ry, comma, Rz, that in the sense, I'm converting these delta, I mean, star things into delta. If I'm writing some Rx is equal to some function of R1, comma, R2, comma, R3, then I'm converting these delta configuration into star configuration. This is a plain rule, and I'm giving some formulas for you. Just look at this. Even if I'm having Rx equal to some function of R1, R2, R3, in the sense I'm converting delta into stars. Like if I want to find Rx, if he has given some delta configuration, just remember these notations. It's the main important thing. Likewise, like here we have R1, R2, R3, and here we have Rx, Ry, Rz. We will start from Rx, Ry, Rz, and we will start from R1, R2, R3. These notations have to be in same, otherwise we will get wrong in our formulas. Some wrong answers in our formulas. If I want to convert this R1, R2, R3 into some Rx, Ry, Rz, then for getting this Rx equal to in function of R1 R3 by R1 plus R2 plus R3. Just consider this formula. And similarly for Ry, we have R1 R2 by R1 plus R2 plus R3. For Rz, we have R2 R3 by R1 plus R2 plus R3. These are the formulas for delta to star configuration. And here we have formulas for star to delta configuration. Just look over here. Here, if you want this R1, if you are converting from here to here, like now, if you want this R1, to get the R1, we have some function in terms of Rx, Ry, and Rz. That is Rx, Ry plus Rx plus Rx, Ry by Rz. These are the formulas. Just by heart these formulas. Then we will discuss some problems regarding these questions. Then you will get it. It's a simple topic. This is a typical question for star delta transformations. And the question will be like, convert the delta configuration into an equivalent star configuration. Here what we have? R1, R2, R3. Here what we have? In star. Rx, Ry, Rz, right? This is delta. And we have to convert it into star form, right? Instead we have Rx equal to R1, R3 by R1 plus R2 plus R3, right? It is delta. And we have to convert it into star. And I will get this. R1, R2, R3. What are here? Uh, just consider 1, R1, R2, R3. R1, R2, R3. How am I taking this R1, R2, R3 configurations? That's the main thing. Just like in star, I have one node facing up, right? Just take that node as one of the thing in delta. In delta, you might have like this thing, right? Here we have something facing upwards. This is facing upwards. In star, it's facing upwards, right? You have to make this upwards parallel so that here R1, here Rx, here R2, here R2, here R3, here RZ. Just try to flip it up. So now this configuration will become like this, right? Here in this side we get RD, in this side we will get RA, and in down we will get RC. From our actual notation, it's R1, it's R2, and it's R3. So I directly wrote this formula. Now check out these values. I will substitute RB into RA by RA plus RB plus RC. That's the thing. Just try to solve out these examples, you will get everything. And I'm giving you this problem as exercise. Just convert this star configuration into delta configuration. And I'm giving the formulas also. Rx plus Ry plus Rx Ry by Rz equal to R1. Here already for us, these upward normals are made parallel. So we can directly write it as Rx, Ry, Rz, and it as R1, R2, R3. Then try to equate this R3 as R31 something according to the notation they have given. When you are writing your final answer, just try to mention this thing what they have given. That's it. For star delta configuration, we have some direct formulas. Just by heart these formulas and try to make these verticals parallel so that you will get a clear idea where I have to use Rx, Ry, Rz and where I have to use R1, R2, R3. That's it. If you are able to know these things, then every question in star delta configuration will be very easy for you. Trust me, that's it. There is nothing more than that. With this topic, I'm concluding the discussion on DC circuits. DC circuits are completed. Now, from next video onwards, we will discuss AC circuits. I think this is all up to for this video. Thank you guys. Meet you in the next video. Bye.